Hi students, welcome to Max Point of View. Today we are going to solve all the numericals which is there in your textbook from the chapter Refraction of Light, the two parts. See, simple application of refraction of light. So in that what we are going to learn, real depth, apparent depth, shift and all. So these are the formulas we require to solve all the numericals. See, this is a symbol for refractive index. We already know from the beginning of this chapter. Part A we are learning R represents real depth, A represents apparent depth. Okay, real depth is also called as actual depth. Actual depth or real depth. The symbol we are going to use is R. R means the complete depth. Apparent depth means how much it has. Okay, the left after raising, how much it has left. This we have understood from the concept as well as the theory solution. Then shift. Okay, listen. First I'll draw the diagram. Then only you will understand the concept. See. If you draw anything like assume this is the real depth, this is the real depth. Now the object is here, this is the real depth, correct? So this object appears to be raised, the depth from the surface till the object, the depth from the surface till the object which is appears to be raised is called apparent depth. Apparent depth, how much it has raised. So this has raised from this point to this point, that is called as shift. This understanding you should know. This is the real depth from the surface to the object, how much it has raised. From the surface to the object, how much it has raised, that is apparent depth. Next, how much it has raised from the real depth, from the bottom, how much it has raised, that is shift. Whenever they are talking about it has raised for 4 centimeter, then it is shift. Apparent depth is from the surface to the object, how much it has raised. Shift is nothing but how much it has raised, that is shift. This concept you should know to solve all the problems. I'll keep this diagram here itself to make sure we are understanding all the questions. First numerical. A water pond appears to be 3 meter deep. If the refractive index of water is 4/3, find the actual depth. See, first, don't worry about the question what we are finding. First, we need to understand the question. Without the final, what we are going to find, we need to understand what are the given data. The water pond appears to be 3 meter deep. Appears to be, that means it is not the actual or real depth. Appearing depth is nothing but apparent depth, correct? Whatever they use the word appears to be, that is apparent depth. It is not the actual depth. It appears to be, it is not real. Appears to be 3 meter deep. So apparent will be 3 meter, and the refractive index or answer we can say that is 4/3. Then find the actual depth of the pond. We have to find the real depth. Actual depth is nothing but the real depth. Keep this in mind. Okay, these are the given data. Okay, so which formula we have to use? They have given apparent depth, refractive index, and we have to find real depth. So here whenever it comes to only real depth, apparent depth and refractive index, we will use this formula. If it is related to shift, we have two formulas. Here. This is the simplest formula. If real depth and apparent depth is given, we can use this formula to find the shift. Very easy formula. If apparent depth is not given and we have to find the shift, then we go for this formula. Okay, anything is fine, but we need to analyze what are the given data. So in this question, refractive index, real depth and apparent depth, first formula. So mu is equal to R by A, and we need to find R. So R is equal to mu into A, correct? If you send this one this side, mu into A. Mu is 4/3 and apparent depth is 3. 3 get cancels, so the remaining will be 4 meter. Okay, so here listen, if apparent depth is given as 3 centimeter, the final answer will be in 3 centimeter only. Don't do the conversion, okay, in the beginning itself. If you do the beginning itself, sometimes if it is given in the centimeter, if you want to convert into meters, it will be decimal, so it will be a confusion. So whenever these kind of questions are given, in this case, okay, don't convert in the beginning itself. Okay, keep it like that. Finally, whatever the desired unit they are asking, okay, all most of the time we have to keep it in SI unit. Okay, so here it is given in meters, that is SI unit, no need to convert it. If given in centimeter, calculate the final answer. Okay, final answer, then if we can, whatever the answer we get, that will also be, if this is in centimeter, this will also be in centimeter. Finally we can convert. Okay, so that will be easy for us. Our second question, a coin is placed at the bottom of a beaker. Okay, a coin is placed at the bottom of a beaker containing water of refractive index 4 by 3. So second question, refractive index is given as 4 by 3 to a depth of 16 centimeter, to a depth of 16 centimeter. Have they given, it appears to be depth of 16 centimeter and all? No, right? If they are not using any appears to be or raised, all those things, it is, if it is not used, then it is real depth. So they are talking about depth of 16 centimeter, that is nothing but real depth, that is 16 centimeter. Don't convert into meter here itself. Finally we can convert it. Then by what height the coin appears to be raised when seen from vertically above? Many students will get confused here only, whether they have to find apparent depth or shift. When they are using it appears to be raised, it appears to be raised, then definitely they are talking about shift. So appears to be raised means they are definitely talking about shift. So we have to find shift. Using refractive index and real depth, how can we find shift? See, if they have given apparent depth, we could have gone for this simplest formula, but we have to go for this formula because we have to find shift, real depth and refractive index is given. Don't worry about it. We'll make sure this refractive index is always in fraction form, so that it will be easy for us to substitute. So the formula is, we need to find shift. S is equal to R 1 minus 1 by mu. So R is 16. Don't worry about the conversions. Let it be in centimeter. Finally we can convert it. So 16, 1 minus 1 by 4 by 3. Correct. So here 1 by 4 by 3 we can write it as, if you take, okay, reciprocal, it becomes 3. 1 by 4 by 3 is nothing but, if you take the reciprocal, it becomes 3 by 4. It becomes 3 by 4. Correct. Now 16, 1 minus 3 by 4. 1 minus 3 by 4, it is nothing but 1 by 4. Correct. 1 minus 3 by 4. In 1, if you take 3 by 4, it will be 1 by 4. Correct. If you can go for any method. Next, 4 1s are 4 4s are. Answer will be 4 centimeter. So what we are finding? Shift answer will be 4 centimeter. If you convert into meter, okay, it will be 0.04 meter. Anything is fine. You can keep the answer in centimeter as well as in meter. So write it in both the forms. Okay, but make sure whenever you are converting, you are using the proper converting value, or else you'll end up in different wrong answer. You will lose marks. You can keep it here for safer side. You can always keep it in SI units. That's it. Our last question, a postage stamp kept below a rectangular glass block of refractive index 1.5 when viewed from a vertically above it appears to be raised by 7 mm. Calculate the thickness of the glass slab. So if you understand the concept, first we'll write the given data, then I'll make you understand what exactly we are finding. So this is question 3. Okay, refractive index is given as 1.5. See, in these kind of numericals, make sure refractive index is in fraction. It is in fraction. How do you convert this 1.5 into fraction? That is nothing but 3 by 2. Okay, so if it is in fraction, we can get the answer in a easier way. Next, when viewed from a vertically above it, it appears to be raised. Whenever they use appears to be raised, that means they are talking about shift. So shift is given as 7 mm. Don't worry about the unit, we'll convert it later. Next, calculate the thickness of the glass slab. What do you mean by thickness of the glass slab? Okay, see, if you write like this, Okay, they are talking about the thickness of the glass slab. You can take this one or from this point to this point. Thickness of the glass slab is nothing but the real depth. Thickness of the glass slab or the complete height of the pond, all those things represents real depth. So we have to find the real depth value. So using refractive index, shift, and we have to find real depth. Which formula? This formula. So we'll first write the formula. S is equal to R 1 minus 1 by mu. So what is S? 7. R we have to find. So we'll send first we'll make sure we make it as a fraction and then we'll send it that side. R into 1 minus 1 by mu is nothing but 3 by 2. See, they have given 1.5. We have to convert into fraction to make the calculations easier. So 1.5 is nothing but 3 by 2. So 3 by 2. So 1 by 3 by 2 we can write it as 2 by 3. 1 by 3 by 2 we can write it as 2 by 3. If you are still confused with this one, you try to understand one more time. Okay. So then 7 is equal to R. See here, out of 1 you are removing 2 by 3. So this becomes 1 by 3. 1 by 3. So now 7 R 1 by 3. Correct. If you move this 1 by 3 that side, this 3 will go this side. So it is nothing but we can write like this. R by 3. Correct. R into 1 by 3 is nothing but R by 3. So R is equal to 7 3 is a 21. Initially, what is this 7? 7 is nothing but it is in mm. So this will be in mm. If you want to convert into centimeter, R is equal to 2.1 centimeter, because 1 mm is equal to 1 by 10th of centimeter, or else 1 centimeter is equal to 10 mm. Then you have converted into centimeter. If you want to convert into this one meter, okay, it is 0.021 meter. That's it. So if you write here only, okay, for this value only you will get full marks. Okay, these values are just for a safer side. You will get full marks here only. Don't worry about it. Try to, if it is in millimeter, try to convert in centimeter. That is enough. So now we have solved all the numericals which is there in your textbook. Understand the concept, which formula we have to use, what is given, what is appears to be raised. Appears to be raised means they are talking about shift. The depth appears to be means apparent depth. If they are just talking about depth, that is real depth. And what is real depth, what is apparent depth, what is shift? If the meaning, if they are asking you to find the thickness of the glass slab, that is nothing but real depth. All those things you should know. So here in these kind of thing, okay, numericals, refractive index should be in fraction so that it will be easy for us. Okay. So I believe you have watched the concept video, then theory, after numerical, this video, then you have learned the complete concept about simple application of refraction of light. Thank you.